Without a calculator. Pi over 4 is how many degrees? Pi over 4 is a quarter of pi. So it's 180 divided by 4, which is 45 degrees. Pi over 4 is a fourth of pi, which is 45 degrees. 40. What are the side lengths in a 45, 40, 90 reference triangle? This is half of a box. These side lengths are the same. And then if you did Pythagorean theorem, you could figure out that the hypotenuse is square root of 2. Okay? That being said, what's the sign?
Root 2 over 2.
Yeah, root 2 over 2 or 1 radical 2. Both are perfect. Okay? At this stage. You know we're supposed to simplify the radicals back in the day. So I want to know what the slope of the tangent line is at this point. Okay? What's the first thing I need to do? Take the derivative. What's the derivative of sine x? That is cosine of x. Now what do I do with my cosine of x derivative function? What's that? Where are we at today, guys? Everyone should be doing this together. We're all doing this together. We're not doing whatever we feel like. This is actually, we're trying to learn the inverse trig stuff. Other stuff you have all this time to work on at home. If you have questions, ask. I have my derivative function. How do I find what the slope of the tangent line is at pi over 4, comma 1 over pi over 2? 1 over radical 2. Plug in just the x value. This one is just determined on the x value. So what is the cosine of pi over 4? Same thing as the y value. Y prime of pi over 4 is going to equal 1 over radical 2. Questions on that? Good? Okay. If I want to know the inverse function of y equals sine x, what do I have to do? Flip the x and the y. I get x equals sine y. Now how do I get y by itself? That's the only way to do it. This is the same as y equals sine inverse of x. This says the same. Or y equals arcsine of x. All three of these things say the same thing. This is still your input and that's your output. But in this case, I don't know how to solve for it in that case. You'd actually have to inverse sine both sides, really, if you wanted to free it. Which would leave you with this. Okay? But if I wanted to do this by hand, or if I want the derivative, how would I take the derivative of this thing? d dx both sides. When I d dx this side, what happens? I get 1. When I d dx this side, what happens? Derivative outside in. The derivative of sine y is cosine, leave it alone, times the derivative of what's inside. Does that make sense? So y prime is equal to 1 over the cosine of y. So now, here we can plug in values. So I have the point, if this is my point on the original graph, then on the inverse I have 1 over square root of 2, comma, pi over 4. So if I wanted to know what the derivative was at the point 1 over radical 2 on this graph, here's the equation that does it. And in this case, check it out. This derivative equation is only in terms of y. You see that? So if I plug it in, y prime at the x value of 1 over radical 2 for this inverse function is equal to 1 over cos of pi over 4. What's cos of pi over 4? Yeah, so this becomes 1 divided by 1 over radical 2, which is the same as 1 times radical 2. Bam. it that way. You can do it. This is how you find the inverse sine. This is the inverse sine equation. It's just not solved for y. But you can still go through it and get your values. I would suggest not doing that. What I would suggest is memorizing these things in this section. Specifically, the inverse sine and the inverse tangent. Which those out of everything come up more than anything else. Okay? The inverse sine and the inverse tangent. If they throw any inverse on you, that's what it's going to be. It's going to be the inverse sine or tangent. But on your flashcards, what you should practice is all of them. You know what I'm saying? Just to make your life easier. The equation for the inverse sine. Derivative. Question?
Why not cosine?
What about it? Why doesn't it show up a lot more?
Why cosine? Because you said sine and tangent.
I don't write the test. So like looking at history, those are the two. If anything's going to come up, it's going to be one of those two. Percentage-wise. I don't write it. I mean, if I write it, I'm going to put one on it for you. You know what I'm saying? It's just who writes it. It's just kind of the most common, I guess, you know. But no real reason besides that. The inverse tangent comes a lot more in integrals because it's this nice clean thing, which we'll get to. But we have y equals the inverse sine of something. And in the notes we called it u. The derivative of the, let me get to this. Let me do this right here. Before I say that the original rule. Does everyone quote this right here? Now this isn't the form that the book has, okay? And what I'm going to do is I'm going to continue on and get it in the form that they like. Because what they like is in terms of x. Because then you can just input it. You don't have, because this is in terms of the output. You know what I'm saying? You'd have to figure out, the derivative would be in terms of the output. That's kind of tricky and messy. But we want the derivative to be in terms of the input, the x value. Does that make sense, you guys? So what they use is this old rule right here. Sine squared of something plus cosine squared of something equals 1. Do you guys remember that? Sine squared plus cosine squared equals 1, yes? Again, as long as these two are the same thing, it's just sine squared of something. Sine squared plus cosine squared equals 1. When those two things are the same thing. If I solve this for cosine squared, I get cosine squared y equals 1 minus sine squared y. Cosine y equals the square root of 1 minus sine squared y.